Okay, this is our midterm review section 2 on matrices. This will be primarily a calculator exercise, but there are a couple of wrinkles in here where we can or perhaps need to do things without a calculator. So let's get started. To begin with, we're going to need to define the four matrices that we'll be working with in our calculator. Now, I've previously gone ahead and set these up, but I left the first one empty so we can practice going through that. So I'm going to move over here to the edit menu. I'm going to edit matrix A by selecting option 1 and first define the dimensions. This matrix is a 3 by 3 matrix, 3 rows by 3 columns. It has the elements 4, -2, 1, 3, 0, 8, -5, oops, double negative there, -5, 7, and -1. And you want to take a look at this. Now, I caught that first mistake as I entered it, but you always want to take a look at the end to make sure that you've got it entered correctly, because you'll have no indication otherwise that your answer is incorrect. All right, now we've got all our matrices entered. If we want, we could go out, quit out to the command screen. We can display the matrices one at a time. There's matrix A, matrix B, and so on. But we're ready to go. Now, looking at question number 1, we can go ahead and just enter that question into our calculator as, let's see, 2 matrix B. So the scalar 2 times matrix B, so that means we multiply each element inside the matrix by 2. And then from that, we're going to subtract 3 times the matrix A. And of course, if you're thinking ahead of me, you may have noticed that matrix B is a 2 by 2 matrix, and matrix A is a 3 by 3 matrix. And one of the very first things that we learned in the matrix unit was that matrix addition and subtraction is only defined for matrices that are that have the same dimensions. So if we press enter at this point, we're going to get an error message. Dimension mismatch. And that usually means you've either defined the matrix wrong or the dimensions just don't match like they do in this case. But in any case, we can't do the operation. So for this one, we're simply going to write undefined. All right. Number 2, CB. This is a multiplication. Now, we had another rule for multiplication to determine if it was defined or not. We said we need to take the dimensions of the first matrix, in this case C, which is a 3 by 2 matrix, and write that next to the dimensions of the second matrix, in this case a 2 by 2 matrix. We look at the center numbers, and in order for the product to be defined, those two numbers have to be the same. In this case they are, so we know the product is defined. So let's go ahead to our calculator. We'll quit from this error message, and we'll go ahead and try this new operation, CB. So matrix C, matrix B. And we get a 3 by 2 matrix as a result. Just slide this over and we'll write down our answer. Let's see, the elements are 40, 40, 30, -26, -5, 19. So that's our answer for number 2. Number 3 asks us, what will the dimensions be of matrix AD? Of course, we could use the same method that we did up here to figure out what the dimensions are going to be. But since we have our calculator and we have all the matrices entered, we'll forego that. We'll just enter the multiplication and we'll see if we get a result. If we do, we'll just look at what the dimensions are. So matrix A, matrix D, and we do get a result. Its dimensions are 3 by 3. So there's the dimensions. Question 4 asks, what is that product? So we'll just jot that down. -5, -8, 15, 30, 41, -68, -21, 16, and 14. So those are the elements of our product matrix. We're then asked in number 5 to take the inverse of matrix B. Now I'm going to go ahead and show you how to do the inverse without the calculator, and then we'll just double check our result using the calculator. Okay, so doing this by hand, since it is a 2 by 2 matrix, it's not that hard. We first need to find the determinant, right? Because the formula is 1 over the determinant times this kind of weird matrix where we take and reverse the first element and the last element. We wrote it this way, dA. Started out as A, B, C, D, and we switched the positions of D and A. And we changed the sign of B, and we changed the sign of C, right? So in order to do that, we first need to find the determinant, and that's question number 6. So the determinant of a 2 by 2, we're simply going to take the product of this diagonal and subtract the product of that diagonal. So in this case, 10 times 2 minus 5 times -3. So that's 20. A little more readable. 20 minus -15, so we'll just say plus 15. So the determinant, let's get the calculator out of the way here. The determinant of matrix B equals 35. So back over here, we're going to write this as 1 over 35 times, we're going to write this as 2, -3, 5, 2. And we could go ahead and do that scalar multiplication, but we're going to double check our answer with the calculator anyway. So we'll just do the inverse on the calculator. Second matrix B, and then we'll press the inverse key. B inverse. And it gives our answer as decimals, and it's very unlikely that the midterm will have a choice with those decimals in it. So we're going to press Math Frac, option 1, to change this to fractions. And on this calculator, we don't have the option to make that the default, so we have to use this conversion option to find that. So we'll just go ahead and record that answer from the calculator to our paper. 2 over 35, 3 over 35, -1 over 7, 2 over 7. And if you look at the scalar multiplication, you can see 2 over 35, for example, 2 over 35, -3. I'm sorry, that's positive 3 over 35. Let's see, why did we get negative there? Because I didn't write this correctly. Let's fix that. This needs to be positive 3. This needs to be -5. And this 2 down here needs to be a 10. There we go. So we switched these two, their positions, and these two we just changed their signs. Okay, so there's our answer for number 5, and our answer for number 6 right over here, 35. That's our determinant. 7 and 8 are a little bit more involved. These are solving systems of equations by using matrices. And note the way that the question is written. It says for each system, write the matrix equation that results from the system. So what we're asking you to do here is set up the matrix equation. This is the manual part, and there will be questions on the midterm that ask you to set these up. Now we once we set this up, I'm going to show you how to just put it in the calculator as an augmented matrix. The way this worked was we took the coefficients for each of the terms, and we wrote that as a coefficient matrix, 3, 1, 4, -2. We multiply that by our matrix of variables, x and y, and that equals our solution matrix, our answer matrix, -2, 5. Okay? Now, to actually solve this for x and y, what we needed to do was multiply by the inverse of the coefficient matrix on both sides. We're going to multiply on the left for each of these to solve. That's the part we're not going to do by hand. We just asked you to set it up by hand, so we'll do the other one. 2, -3, 5, 2 times xy equals 4, 1. And you would find that if you multiplied this times the inverse of this, here you would get, on this side, you would get the identity matrix 0, 1, 1, 0. On this side, you would get the actual solution. But in the calculator, much, much easier. And we're letting you use the calculator for these, so let's do it the easy way. We're going to define another matrix. Actually, I think I have one of them defined already. Go second matrix and edit matrix E. You'll see that I've already got this defined. I have the coefficient matrix here, 3, 1, 4, -2, and that is augmented by the answer matrix. And all we're going to do, we're going to quit from here, go back to the command screen, and we're going to run this command from the matrix menu. We have to get out to the command screen before we do this. And it's all the way down near the bottom. RREF stands for Reduced Row Echelon Form. Calculator is automatically performing a set of row operations for us that put the matrix into reduced row echelon form. Plug in the name of the matrix we want to work on. That's matrix E. Close the parentheses. It will spit the matrix out in reduced row echelon form. Notice that our answers are given as decimals. You may have a choice that has decimals in it, or you may need to press Math 1 again and convert that to fractions, which is what I'm going to do. So for this matrix, x equals, or for this system of equations, I should say, x equals 1/10, y equals -23/10. And for problem number 8, we'll define a new matrix. Edit matrix 6, or F. This is going to be 2 rows by 3 columns containing the elements 2, -3, 4, no, not 44, but 4, there we go, 5, 2, and 1. And again, double check and make sure we've got everything entered correctly. I see that my 3 should have been negative. We'll fix that. Everything looks good now. Quit back up to the command screen. We'll run that same command again. Second matrix math, and it's option B. I can push alpha B here. Plug in, whoops, okay, hit something twice. There we go. RREF, and this time we're going to plug in a reference to matrix F. Option 6. Close parentheses, enter. And you see again, we get the identity matrix over here in the first 4 elements. And over here we get the decimal approximation of our solution. We're going to change that to fractions again. Math 1. And our solutions over here. X equals 11/19. Y equals -18/19. that is our matrix practice.